Hello and welcome to lesson number 7. This is the second lesson in Unit 2B in our grade 10 academic math class. This is the cosine law. So as promised, we've finally arrived at the portion of the trigonometry unit where we step away from right-angled triangles. Stepping away from right-angled triangles, however, has robbed us of some of the tools that we've developed over the first half of this unit, specifically the Pythagorean theorem and the primary trig ratios. And the reason is that without a right-angled triangle, you don't have a hypotenuse in any of the triangles that are not right-angled triangles. There's no hypotenuse. Hypotenuse is specific to right-angled triangles. We know that the Pythagorean theorem uses the hypotenuse as the c value, the c and the c squared equals a squared plus b squared action. And we also know that we've created many, well, at least two, of the primary trig ratios that we worked on, sine and cosine, both have a hypotenuse in them. And without a hypotenuse, the whole system sort of falls apart. So we've essentially lost 2 out of the 3 tools that we were developing in the first half of this unit. And we need to reclaim that if we want to still be able to find missing side lengths and find missing angles. So the first way we're going to explore this is the cosine law. In the cosine law, which you can see, and again, you might want to pause this if you haven't already, and just sort of copy down the beginning of this note either on a blank piece of paper or in the skeleton note itself. What you're going to notice is that it looks an awful lot, I'm just going to zoom in here, it looks an awful lot like the Pythagorean theorem. Specifically this part right here kind of has a Pythagorean theorem kind of vibe. And essentially, the cosine law is a vamp on the Pythagorean theorem with this little piece added here at the end that accounts for the fact that it doesn't have a hypotenuse. It has a longest side, but it doesn't have a hypotenuse. So that's how they, without getting too into it, that's how they developed the cosine law. And the cosine law is going to help us find a couple of different things. It can help us find missing angles, and it can help us find missing sides. So what I've done is I've taken the liberty of sort of dividing it into sort of 2 different versions. Technically, this one over here on the left, that is the cosine law. But the other one is a reorganized version of that, where you have the angle C that you see there at the end. Angle C is sort of hanging out over there, isolated, which is cool. So there it is, hanging out on the end. So that's good times. Let's go have a look at the things that it can help us find. So here we have the cosine law set up to solve for side f. Now there's this triangle over here on the right. Again, what you might want to do is just take a moment here and pause and copy down the I and II that we've got here coming up. So maybe do that now and then we'll come back and we'll talk about this. Okay, so you've got them copied out. We are going to be able to try to find a side, and we're going to be able to try to find an angle. So if we are trying to find a side, as you see here, what we've done is we've taken side little f, which is the one that we are trying to figure out. We've started it with an f squared. And what I want to point out in terms of patterning, because you're going to need to memorize this, is that the only other time an f shows up in this is the reference angle. I guess it's not a reference angle like it was in the last unit, but or the first half of this unit, but just a reference angle, the only other angle that we reference, it shows up right at the end. So I think it's unique that we have this, like f shows up at the beginning and at the very end, but nowhere in the middle. The other thing I'd like you to notice is that the d value shows up twice, and the little e value shows up twice as well. So f, the one that we're trying to find, is the only one that shows up once in this equation. Now we've further isolated f by taking the square root of it, which is what we see here in this last part. So that is a reorganization, or I guess a reapplication of the cosine law using some different letters. We're going to do the same thing to try to find angle D. So we're going to be using the second version, the one over here that we said we used to find an angle. And again, I want to point out something in terms of the patterning. If we're looking for angle D, what I'd like you to note is that side little d only shows up once, and it shows up at the end, and that's where it must show up. It can't be minus e squared, it can't be minus f squared, it must be minus d squared. It must be matched up. And again, I'd like to point out that side little e shows up twice, and side little f shows up twice. So these are just rewritings given a new triangle, a different way of looking at it that isn't, as it is listed above, all a's and b's and c's. You can use any old letters that you like, which is cool. So let's head off and try an example here. The first one we're going to do is using the cosine law given, given 2 sides and then a contained angle. So 2 sides and a contained angle, that's side angle side. That all the way back at the very beginning of this exploration of trigonometry when we were talking about ways to prove that triangles are similar. I promised that we would have two sides and a contained angle, and here we are using it. Again, just further reinforcing the role that similar triangles plays in underpinning all the thinking and all the logic behind trigonometry. So I've taken the opportunity here to draw out that little table that I like to draw, as well as the triangle. Now I will say straight up, I don't make any effort to draw a triangle FDE or DEF in any way accurately. I'm not measuring the side lengths, I'm not measuring the angles. It's just a reference for me so that I can lay things out properly. So we have this triangle DEF, and we have angle D equal to 50 degrees. Let's fill in a few things here. Angle D is equal to 50 degrees. There we go. And we'll put 50 degrees up in our table as well. We have side little e is 10, so that's over here. And there's side little e over here is 10. And lastly, side little f is 8. And sorry, these are meters. And that was side little f, I think I said. Yep, was 8. So what you're going to notice here is, based on this setup, we're being asked to solve this, so we're going to find all the missing values. But you'll notice that we have a side, and the angle contained between it. That is the right setup here for us to be able to find the other side, this piece over here, little d. We don't know what that is. And that's actually where we're going to start. So we are going to start by finding, oh, actually they just want us to find side little d. We don't actually have to solve the whole thing, which is pretty sweet. So let's go find side little d. Again, first thing we're going to do is hopefully recognize that we need to be using the cosine law here, because A, it's not a right angle triangle, and B, we have this configuration of two sides and a contained angle. So let's go and pop that in. We're going to create a cosine law. So we're going to start with d squared. That's the side we've been given. And remember that then we have e squared plus f squared minus 2ef cos of angle capital D. So from here, we're just going to go and we're going to substitute in values that we know. So we know that little e is 10. We know that f is 8 minus 2 times 10 times 8 times the cosine. Now angle D is our reference angle, and that is going to be 50, or I guess the angle that we have been provided, and that's going to be 50 degrees. Now, I'm a big fan of just getting this all done in one step and absolutely letting your calculator do the work. I know maybe you've heard from other teachers, they want to see incremental steps. For me, once you've substituted these values in, this is just math, and there's no reason you should make mistakes here. So I'm going to type in 10 squared plus 8 squared minus 2 times 10 times 8 times the cosine of 50 degrees. And I hit equals, and I get 61.153, etc. Now, I'm not going to be rounding this just yet. The reason is I have one more step to go. So I'm actually keeping this in the display in my calculator because we are at d squared, but we need to get just a straight up old d. So I'm going to just put d down. I'm going to keep that in my actual display, and now I'm going to take the square root of it. This is more exact, and we end up with 7.82, so we're going to go with 7.8 meters. And there we go. So we have used the cosine law to find a side length by substituting in the values after recognizing that we had two sides and a contained angle. There you go. Hopefully that made sense. We have a couple more examples here that we're going to tackle. The video is getting sort of a little bit longer, so why don't I stop it here, and then in the second half we'll tackle these last two examples, and we can get you off to your homework. So we'll see you in part 2.